Yes, Assalamualaikum warahmatullahi taala wabarakatuh. Today we will continue our Gauss-Seidel method, load flow analysis. So basically, we have discussed about the power flow equation, the general equation, previous lecture. So today we will look at the solution of power flow by using Gauss-Seidel methods. Okay, in power flow study, it's necessary to solve a set of nonlinear equation for two unknown variables at each node. So we remember back that we have the equation, uh, the the general equation of the current here, where uh, we can construct the equation in terms of sending end voltage and receiving end voltage, as well as our admittance. Okay, admittance. And then if you remember that we have discussed previously that we can create the voltage when you do the rearrangement, you can get your voltage for the next iteration, K for the current iteration. Okay, let's say K is 0, meaning that the initial value K 0, but for the next iteration you get K 0 plus 1, meaning that V1, meaning that this is the current iteration. So this is the previous iteration. So Vg also the previous iteration, so you can get the value of Vi. Since we need to do it in iteratively, okay, so where the KC in terms of KCL, the current entering bus is assumed to be positive and leaving bus to be assumed negative. And Pi schedule is the net real power in per unit. Qi schedule is the reactive power in per unit. Okay, so we will use this equation where your in terms of pi for the next iteration equals to the vi for current iteration times this one is need to do conjugate, and this one is vi for the current iteration yij minus yij k. This is the current iteration, and then to get the real reactive value, so this one we took at the real value, and then this one we took the imaginary value. Okay, and then for PQ, Phi and Q are injected into the bus such a generator. P and Q have positive values. So this means that, let's say we have the generators because the entering, this is the generator. So that's why your P and Q must be assumed to be a positive value. However, when load, we have load. So P, D, and QD normally we can construct in terms of negative because it's a leaving the bus. So we assume that it absorb the current, right? So that's why when we do the load, your P must be negative. Okay, so negative values here for the P and Q for the load bus because it's flowing away from the bus. So let's take a look at, we have two bus system. So the question is determine the voltage at each bus for the specified load condition. Here we have load 0.3 per unit, P, Q 0.2 per unit. And then we have the series impedance. This is our R, this one our X. Okay, so this is swing bus. So we need to find the PG and QG. For PQ bus, we need to find the voltage magnitude and the angle. So this is the task that we need to do. So the step, this is using the power Gauss-Seidel. Calculate the bus admittance matrix, and then include the admittance of all transmission line transformer between lines, but exclude the admittance. Okay, never mind, calculate this. So we have our Z here. This is our Z. We have 0.1 plus J 0.5. So remember, we need to find the Yij, meaning that Yi12. So one and 2 equals to 1 over Z line. So you get this value. From here, you can use, as you remember previously, we have discussed about to construct the bus admittance matrix. So Y11, we can construct the, because this is a two bus, meaning that your matrix should be 2 by 2. Okay, 2 by 2. And then we do the off diagonal first. Since this is similar, only two bars, so we get the similar value, but need to negative, make it to negate the value here, right? Because it's off diagonal, you need to negate the value of y line. So you negate, you can get negative 0.3846 plus j 1.9231. Similar for this one because this is the mirror. And for the diagonal, since this is only one transmission, so it's a similar value. Just put the value right here. Okay, this one is y11 and y22. So you get y bus. Next, we select the select bus since we have two bus system only. So for sure, the bus number one is the select bus. And then for the load bus, normally we assume that the voltage is start with the one. See the value select bus. Normally will be given or will be determined before you start your calculation. And then we select the initial estimate value for all voltage. Normally we start with V2 also similar V1 V2 1 per unit 0 degree angle, and then we write the voltage equation. Okay, so since the bus 1 is the generator bus, select bus only we need to solve by the uh, load bus first because start with 2. So this is voltage bus 2 by using the equation, right? So V2 y 1 over y22, and then we have P2 minus JQ2 divided by V2 all. V2 all meaning that this is your voltage V2 all conjugate because we have one only, right? So no problem. But for the next iteration, it will be different. And then remember that our load bus is minus. So you need to minus 0.3 because our load is 0.3. So it's minus 0.3, and then Q2 also minus 0.2. Okay, so that's why you need to put minus. But the equation here, we have minus JQ2. So minus minus will become positive. So this is where the student always make mistakes. Okay, so be careful here. And then this is where you put the value of y22. This is from the bus emitter matrix. This one is 1 unit 1, so should be no problem. Minus y21, this is y21 negative, times v1. So since v1 is 1, should be no problem. You can verify the the solution. Okay, you can verify the solution. This is the for the first iteration. Okay, so for the next iteration, you need to update the value. Since we have two bus, should be no problem. So you need to update the value. Okay, so this is the first iteration, right? So this, you need to use your calculator. So that's why in my class normally I will ask you to calculate these things. So since this is the asynchronous, so should be no problem. So there's a value here. Save, and then please make sure that this value, don't forget, will be used in this value. Okay, because this is the updated value of your bus number 2. Okay, everything is similar, but your voltage here will be different. So you can get the new value of your uh, the voltage bus number 2 for the second iteration. For the third iteration, this value need to be used in here also. So as you can see here, if you make a mistake here, so you will get all the way your answer is wrong. So be careful. Okay, because iteratively will be your result will be bring to the forward iteration, and then you compare. Maybe you need to compare, or sometimes this question will be stated until how many iterations. Okay, and then check the results, and then typical value for the phase angle is less than 45 degree. So let's say your final iteration you get 0.8315. The angle is minus 0.98 minus 8.994 per unit. Okay, so let's say we have this value for V2, And then since we know that our V1, because V1 is 1 per unit, so we can find our current flow here. So I12 equals to V1 minus V2 divided by Z or times your Y. So you get your current 0.433 minus 42.65. So the final problem is we need to find the PG as well as QG, right? So we can use this equation. S equals to VI conjugate. This is uh, your voltage at bus number 2. Okay, and then times I conjugate, meaning that your current the voltage here is 0.2999 plus J 0.1997. Okay, that is this is almost equal to the power being consumed by the loads. So this is what we want to confirm, that our power is minus 0.3, right? 0.3, this one is 0.2 for reactive. So we can say that this value is correct. So once we can get this thing, we can get uh, the P and QG. Okay. So I think that's all for this class. Later we will discuss in detail for other example when we have the continuous class. Okay, synchronous class. So because I have another personal matter, so that's why I need to do this video for the asynchronous class. So hopefully we can discuss detail before we go to the other techniques. Okay, that's all for today for this session. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.